Yeah, good morning, everybody. So today is the session 5, and today we'll be talking about workloads, configuration, metrics, and auto scaling, and a Kubernetes dashboard. Okay, so coming to workloads, workloads like it's an application running on Kubernetes. Whether the workload has a single component or several, it runs inside a set of pods. So once a pod is running in the cluster, then whenever the node gets failed or anything is happened, that means all the pods running in that nodes are also failed. So Kubernetes, what it does, it treats like it's a node failure, and it starts like a backup process. It starts to create the nodes in other working nodes. Even if at all it comes live and healthy in between, also still it will not create the nodes on that pods on that particular node, and try to recover them on the other working nodes. Okay, so there are different type of so workloads are available in Kubernetes. We'll talk about one by one. First is about the replica set. Replica set is its primary method is like managing all the pod replicas and their life cycle. Its job is that, so that includes like scheduling, scaling, deleting, everything, whether it's scale up or scale down. All these process is maintained by the replica set. So whenever we mention like how many desired replicas we need, here in the example you can see like I'm saying 3. So it always ensures that these desired replicas are available and running in the cluster. Okay, and the selector is that replicas is like how much our desired number of pods we need, that we need to mention. Uh, this is the example of the YAML file, how we can mention the replica set. So here in the selector, it will give all the labels like pods in which environment, and everything is given in the labels selector part. Here I'll show you how we can create those. So here, like I have created all the files, YAML files, and saved. I'll also share those things. Okay, so if you see, this is the same replica set which I have created there. I'll be explaining here. This is a replica set. This is a sample file, the same sample file which I am using here. So here it is, we specify how many replicas we need and what is a template, and in the specifications we mention like what is a container name and what is the image we are using for that replica set. Here example, I'm taking the Nginx. It can be anything based on your application, and the what is a container port. Suppose example you are running a Tomcat application, then container port will be its respective to 8080 or 8081, whichever you define. So that need to be specified in the template body. Okay. So right now, if I say kubectl get pods, I don't have anything right now. So what I will do is I will apply this file rset example.yaml. Okay. So now, yeah. So if you can see now, like there are 3 replica sets have been created. Okay, so because we have given the replicas as 3. If at all I want to increase more, I can directly edit this and apply. Example, I will make it to say 6. Apply. Okay. So now if you see, it's created. Earlier it was 3. Now it has created 6. Like at all, you can even scale down if at all we don't want. will say 1. Now it started terminating those things. So this is the process of replica sets. Likewise, we can also use these replica sets in horizontal pod autoscaling, which I will explain you in the coming slides. Okay, I forgot to describe. Okay, so next is the deployment. This is the kind deployment. Earlier we saw like its kind is replica set. These are all the workloads. Okay, now we'll talk about deployment. Deployment is nothing but it's like a way of managing replica sets. Okay, so this will provide my other functionalities like rollback, update control, and it will also like labelings we can do, and each and every deployment sets, it will be having a hash template. It will be labeled through a hash template, and it creates iteration so that we can roll back, we can update or roll back based on those things. I'll show you all the examples. Okay. So here the same, just now we saw like a replica set. Here we are doing kind of like a deployment, and here's the same replicas we are maintaining. Yeah, it's the same file which I'm using. So now if you see, right now there are no deployments. So now I will deploy this. By -f. Sorry, spelling mistake. Okay. Now you can see the deployment. It is created a deployment name, where we have mentioned in the metadata. This is the metadata name we have mentioned, like the name is Nginx deployment. Still the container is creating. That is the reason still it is showing 03. Let's give some time. Now if you see, okay, 3 are available. Yeah, here because while deploying it says like 0 of 3 are ready and available are 0. Now once all the pods are started running, you can see like 3 out of 3 are ready. Okay. So here also same, if at all we want to increase more replicas, more pods, you can just say 6. So now see 6 out of 6. Okay. Yeah. So it's nothing but just deployment is like it just manages the replica sets. Okay. And next is I'll show you like how the strategy version everything it is mentioned here in deployment. We have like options like we have revision history, wherein replica sets we only just mention like how many replicas we need to have, but in deployment we have many other options. Here like revision history and the strategy. There are two types of strategies. One is recreate, and other is rolling update. Recreate is nothing but just destroys everything, all the existing pods, and it will try to create the new ones. Okay, that's old fashioned, but right now like most of the people prefer using rolling update, because it does not disturb the existing one. It's some and it will update one by one. Here if you can see the YAML file, here we are mentioning like max search 1, max unavailable 0. Okay, and the revision history 3. Yeah. So first let me remove this. If at all you want to undeploy, you can just say delete the same file. You can just mention delete the file and it will delete, or there is also other option called you can directly get deployments if at all you don't have this file. Okay, so how you can delete in this way also. kubectl delete deployment, the deployment name. Okay, now if you see get deployments, now get pods terminating. Okay, it's gone. Let me remove this set. Okay, yeah, so I'll apply this file. Okay. I have created another file. Match template labels. Selector build st3. Everything looks fine. Okay, I'll show you in a command line way, which I have also mentioned here. Okay, the same it is the same function it does. Okay, so I'm creating a deployment. So I've created one just deployment with the image Nginx, the name as test. So it is creating. Okay, now what I am doing is I'm just giving it a label. Okay, now if you see kubectl get deploy. Okay, now if you see, okay, so this is the history which we have given. We have annotated this in a version number .1.9.0. So now what we will do is we will set the image. Okay, we will upgrade the Nginx version to 1.9.1, and we are saying it a record. Okay, so now what happens is there are two versions, 1.9.0 which we have created earlier and 1.9.1. Now if you see, so once we updated that to 1.9.1, so it is creating the new version. So it's terminating the old one and creating the new version. So this is the hash template which we were talking about in the beginning in the workloads. So each deployment version will be having a hash template. Okay, so now the latest one 6B is 5F is the old one, 6B is the latest one. This latest one is running. So what we'll do is we'll set this revision to a 1.9.1. Okay, so now we have two revisions. One is like 1.9.0 and the second one is 1.9.1 is a revision. So now now there is the option for the deployment is, if at all we have some issues and we don't want the latest version, we want to go revert back to the older version. Okay, so what we can do is, so this is revision 1 and revision 2. So now what we can do is, like, I can, I will say revision 1. Okay, now we see, So this was revision 1.9.0. Now what I have done is we have roll out to the older version. So now it is moving to 1.9.0, but the revision is changed. Now if you see, so earlier it was 5.6 template hash was running. Now it is 5.7, which is the old earlier version. Now to show you more, I will share. Okay. So now what we'll do is we'll increase the replicas to 3, so that we'll do it to 6. So that we can clearly see like what it does. So let's wait till it creates everything. So now we have 6 replicas running of this version. Now if you go and see which version we have, currently we are running into 3 revision. Now what I will do is I'll revert it to the old version. Then you can see like how it is changing. So one by one, once it starts creating, this is the newer version, and it terminates the older ones. Yeah. So we have 6 again with the latest one. So that is the difference between the deployment and the replica set. So in deployment, we have options for this, revision history and rolling updates, rollbacks. All these options we have in the deployment. That option is not there in the replica set. Okay. And yeah, this is what the same how it does, which I have shown you. So once we do in replica set, 1 by 1 pod, it scales out and deploys 1 by 1 option. Like once it's done all the things, then it will start terminating that. That is the rolling update one. And coming to the other workload is daemon set. Daemon set, it's nothing. It runs on all the nodes, and it will match all the certain criteria. We will run all the instances on the supply. Of the in the particular pod. Okay, for the daemon set, ideal example is like log forwarding. What do you call? Fluentd or Logstash, or for all these, they are run on the daemon set, because those things are need to be run on each and every worker node, and need to be updated the API server, whatever. Example, if you are taking a log EFK node, so Fluentd, what it does is it takes all the logs from the each and every worker node Kubernetes containers, and it will upload to the Elasticsearch. So for that reasons purposes, we use a daemon set, because it needs to be run on each, and it needs to be run on each and every worker node. Okay.
Yeah, before you continue, do you want to stop for a second to let them do the survey? Okay. Could you just stop sharing so I can show them what the survey?
Yeah, sure.
So, like, if you, like before with all our events, and we do a survey for our statistics for to submit to Brampton, as well as to tell people about our like programs and everything. So I'm gonna share my screen to show you what it is. The link is also posted on the chat. You can see my screen, right?
Yeah.
Yeah, Mickey, we can see your scene. Yeah.
Okay. So you go to Cotodon, and at the top tabs, one it's called filled surveys. You will click that, and then you filtered survey over here. And we'll give you like 10 minutes to fill it right now.
Oh, not 10 minutes, it just takes 2-3 minutes.
Yeah, right.
Okay, so let's do this, right? Rambabu, including you and everyone, right? Kindly,
Yeah.
please, if you have an access to the Teams, do that. Or if you don't have access, in the chat of today's meeting, there is a link posted. You can click that link. It will directly also take you to the survey. Okay, let's take a 2-3 minutes for everyone to fill the survey. I kindly request whoever are in the call, let's fill the survey because it's very important for us. We are non-profit, right? So we don't make any money, but we have to show this progress that we have made as an achievement to the city where the non-profit is, and also, as a record for our contribution towards the society. So it's for the great cause, and we are requesting you to fill the survey. Please take time to fill the survey. Right, so the time starts now. Please go ahead.
Yep. I could stop sharing.
Rambabu, are you able to finish it?
Yeah, I've completed it.
Okay.
Yeah,
So I think
7
if one
came in.
person, yeah, this is really good. Right, Rambabu, please continue.
Yeah, you could go ahead.
Okay. Next, coming to is stateful set. Stateful sets are like, they are because they are very valuable for the applications, that are like require stable, unique network identifiers, stable and persistent storage, graceful deployment and scaling, and automated rolling updates. This is the example file of the stateful set. I'll show you how to deploy this. One of the like stateful sets are like, it is not type of like a deployments where they don't share anything between each other. So they are like independent containers. And here, let's show you more state, the same file. CTL apply -f. Okay, you can see here, this is the application sample application which I have deployed, my stateful set. Here you can see normal when we do with deployment, everything is like, with hash, and they are maintained like this way. But coming to stateful set, they are independent of each container, and they are unique to each other, and they have their own volumes attached to them. And whenever we delete this pods, the volumes are retained for the backup purpose. And these are very much useful for like, NoSQL databases and all. For those type of applications, we generally use stateful sets. So here also you can see we have attached a volume called www for this container. So each one has created its own volume claim. If at all I update replicas to say 4, so there will be 4 different, it's like 4 different containers. Yeah, here you can see. So whenever we start creating this, this is the unique way they prefer. I mean, they create. If at all you create 10, it will start creating 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is how this is this maintains. And if you see the volumes also, it will create equally to number of containers. And if at all we delete this, so all the stateful sets are deleted. Okay. Now if you see, all the still volumes are still there. That is the advantage of this stateful sets workload. So normally for like, NoSQL applications or any other similar kind of applications, they use this stateful set options. Normally all the micro containers and all these applications, they are like stateless deployments. But for only whichever the applications which we require stateful, we use this workload. Here this is the service, we say kind stateful set. And the next workload is like jobs or cron jobs. Okay, it is just like a scheduler. To tell in simple terms, it's just nothing but like a scheduler, or you can say Linux cron or whatever it is. And one thing, very important thing to note down is these cron jobs, they only use UTC time zone. So if at all you are configuring any cron jobs, keeping that note that you need to check UTC time and configure it. This is the sample template for creating the cron job example. I'm just creating example. And if at all you want to list like existing any jobs are available or not, you can see, you can type this command kubectl get jobs. It will list out all the existing jobs. Kubectl get jobs. Okay, I don't have anything. This is it will check particularly in the whichever the namespace you are available. To see list out like for any command, if you use -a, it will check everything in all the nodes. Example, if you say kubectl get pods. Okay, so it is only showing in a particular namespace which I am currently there. If at all I want to see like what are all running, just use -a command. This is very useful. So it will list out like whatever command you can use, just add -a. So it will search in all the namespaces and list out. So I'm just getting, so I don't have right now, I don't have any jobs. So I have created the sample file here, cron job. So it is the same file mentioned in the PPT. What I'll do is kubectl apply -f cron job. Okay. Now cron job created. Okay, so it took some time. So this job has created. Now you can see here its completions is 0 out of 4. Here we have given like completions 4 and parallel 2, and successful job history limit is 3, and failed job limit history is 1. I think it is there. No. Okay. So what is like, I will just describe the job. Describe job. Okay. Just give some time. So it starts scheduling the job because every minute. Create. Multiple times created. 70 seconds, 74. Maybe due to okay, let me delete job. Let me delete this, the old one. Oops, I need to delete the different way. Kubectl describe job. Okay. Okay, go hello from $host. So here we list policy. Okay, so all the four are completed. 4 pods. Created pod. Created multiple. Okay, so kubectl logs. Okay, so you can see the log hello from, this is the name. So this it runs like every time it runs, this is the echo for hello from host name. So it keeps on running this for every minute. That's what we scheduled. And it will it will retain successful job history limit. It will retain the three as a 3 times 3 histories, and failed job history it will limit to 1. Okay. We generally normally we can use like cron job. We can useful for like, suppose if at all we are doing any we need to run any crons or any schedulers in the backend. We can use this workload cron job for this purposes. Normally how we do is like, if at all we use any elastic search, we use any EFK thing, then if at all we want to clear up all the old logs or do any other things, for that purpose also we can we generally use this cron job for those purposes, cleaning up the things and all. And other very important thing is the health checks. This is very much important because whenever we create a pod, kubelet only verifies like whether the pod is running or not, and it doesn't see like whether the application is running or not. For example, if we have an Nginx application and our website is running in that, okay, it will the kubelet will verify whether the Nginx pod is running or not, and it will report to the API that whether the pod is running, or if at all it crashes, it will try to generate a new one. But what happens if the application gets crashes and application does not respond, and still the pod will be running? So in those scenarios, it is always better to define health checks. This is the template for creating health check. Here we do like which is the port liveness test. There are many other options like liveness, TCP, many other things are there. Here I'm giving like the liveness. And here are the options like initial delay, how much, if at all your application, you are generating a pod and it to run and start, it takes, if at all it's like any Java Java application at all, Tomcat. So it might be getting delay in starting the application. So here we can mention those settings: initial delay seconds, like number of seconds after the container is started before liveness or readiness probes should be start, and how many seconds it should wait, like what is the period, and how many seconds it should think like it's a timeout, and what is the success threshold, like minimum consecutive success of the probe to be considered after successfully failed, and failure threshold, like whenever the probe fails, it will try to wait for so many times. Of example, here I'm telling like 5, so it will try to wait till 5 thresholds. Okay, after 5 thresholds, then it will notify that it's a failure. This is these liveness health checks are very much important in production applications. Um, if at all like there are multiple 4 or 5 replicas you are running, and in one of the container application is having an issue, but still the pod is running, and the API server will be probing that the pod is running and it is no issue. So if at all we have this liveness, so API kubelet will depend on this, will also verify this liveness and update the API. So whenever this liveness else it's failed, so it will try to create a new, destroy that container and create a new one. So for those purposes, these health checks are very much important. Okay, and coming to the configurations. So Kubernetes says they have its integrated pattern for decoupling configuration from application or container. For those, it has two components. One is like config maps and one is secrets. Okay, both I'll tell you the difference. What is config map and what is secret. Config map, it's like external data storage within Kubernetes, can be referenced with several different means, like either in environment variable, or you can attach to like a file in a volume mount. It can be created from manifests, literals, directories, or files. Like you can create in the command line, or you can create it from a file, like save everything in a file and create it from a file. The many options to create the config maps. This is the example here, like how it's simple, like the properties which we use in the applications. Like example, if you deploy any MySQL application or database or something, so we need to define a username, password. So password or any other variables say maybe the customized port and all other things. We can define all those in config map. Here is example. This is the kind is the config map, and metadata name. I'm just giving my app as an example. This is the data. I'm giving like state Telangana, city Hyderabad, and the content it's like this. So I'll just create and show it to you. Okay. Here you can see we have created this config map is created. If at all you describe, here you can see content. The value for the content is this line. Value for city is Hyderabad, which I have mentioned. So it's nothing but like name key value pair. Just only key value pair. It simple holds that. And how we use this config map references in a application file. This is the example which I'm showing here. So here in environment variable, I'm passing it like name special key example like this. And what I'm doing is value, I need to get it from my config map reference. So what for this value, I need what the value will be getting is, it will refer the config map this name, and it will search for the key state. So what is the state? Telangana. So for this name, the value will be Telangana, like that. So in this way we need to use. And you can say like, why do we need these config maps? Why can't we maintain in the why can't we give hard coded here? So I'll tell you the scenario when it will be very much useful. If at all we have like 3 or 4 environments, say dev, QA, prod, and we need to have different properties. So for that, we can't keep on changing the file every time. If at all we move from dev to production, or production to dev to QA to production. So what we do is, we generate this config maps in particular each and every namespace, and then we use these values, because these are particular to the each and every namespace, not global to the cluster. So every namespace we need to, if at all we need to have multiple environments, then we need to create this in each and every namespace. So during those times it will be very much useful. And the next is the secret. Secret is it's like functionally it's very much identical to config map, and the purpose is also same. The only thing is we save credentials. Okay, credentials like the Git repos or database passwords or any other things, we save it here. So it stores in a base 64 encoded. If at all any person who has access to server tries to retrieve, also he cannot be able to retrieve. And they are stored in the TMPS directory, which is temporary. On each and every worker node they are stored. So if at all they are like they don't save in any file. Ideally what I told, like we use it for like username, passwords, or any certificates. For all those things we use. Here we can see there are different types. Here I'm showing like opaque. For there are secrets within Kubernetes like Docker registry, generic, opaque, and there is a data which contains. So here I'm storing username and password. We can also create with the YAML file. In YAML file, what it is, we need to give in a base 64 encoded content. We need to first convert it into base 64, and then we need to create in the file and create it. If at all you want to create a command line, here is the option. You can directly create it. So I'll show you both ways. First, let me check secrets. Okay, I already have this. Let me, yeah. So kubectl apply -f secrets. Okay, more secrets.yml. So here I have created this YAML file based on the base 64 encoded. So I have to encode this username and password and create it. If at all I want to create on the fly, maybe some typo error. Yeah, so it was copy paste. So the secret got created. Now if you see, so we have created two. One is with the YAML file and one is the command line. Now if you see kubectl describe secret, sorry, my secret. Here you can see type is opaque, so nothing is mentioned. Username is 7 bytes, password is 12 bytes. So this is the main difference between a secret and a config map. Config map, if you describe it, you'll get to know like what all values are there. So if you describe, you can get to know like, okay, this is the value has been assigned to this. We can easily make out. But coming to secrets, no, we cannot see. So that is the reason. That is the main difference between secrets and config map. Both the usage is pretty much similar. You see, and these are many other types of secrets are available for usage like TLS or tokens, for the Dockers or SSH auth. So these type of many other types of secrets. This is a list, and here is the usage. So here I've just put it side by side so to make it easily understand. So the same, the config map. Here the value I'm getting it from key config map key, the name. Here is the same. For the username, I'm getting the secret key reference. The secret key reference is my secret, and the value is username. So the usage and everything is same. Only thing is like they are encoded. That is difference between config and secrets. And coming to metrics. Metrics, metric server, it's like a separate API server which runs on each and every worker node, and it collects everything like what is the CPU utilization, memory utilization of each pod, each node, everything it collects, and it will send it to the API through kubelet node. So okay, here is the example. You can see like how it does. See like how much CPU utilization, what is the memory, what is used. I can show you live as well. I think its connection is lost. What is there? Oh shit. kubectl top nodes. Sorry. Okay, I think I belong into other server maybe. Server name 111. Okay. Yeah, here is it. So it will run on each and every worker node, and it will list out everything, what is CPU utilization, what is the memory utilization, how much it is, and it will summarize and sends it to the API server through kubelet. Okay, so why, this API server is very much useful and very much required for configuring the auto scaling, pod auto scaling. Based on this only, the API server will trigger the new pods based on our utilization. Example, you say like this is a thing. Here is a sample YAML file which I've written for just example purpose. And when you type like this is the command to get to know like what are the configures. kubectl get HPA -a is like get it for everything. So here we give the reference like we use deployment and the name of the application, like how many replicas we need. Initial replicas are 2 and maximum are 3. And what are the on what based metrics we need to enable the auto scaling. Here I'm showing like resource is CPU, and there are two like based on CPU and based on memory. So here in the example I'm showing like based on CPU. So it will create currently it will run 2. When the CPU utilization gets more than 70%, it will start another pod. If at all we configure like say 6. So once the minimum 2 will be running, every time at a time minimum 2 will be running, and if at all any pod utilization goes more than 70%, it will create another one. Okay, so that is and these are all dependent on the metrics from the metrics API server. So for that reason, metrics API is very much important for pod auto scaling. And this is how you write define in the autoscaler how much our configuration unit. Now if you say get HPA -n. Yeah. So here I have all the applications and here are all the targets. So currently their utilization is very, as a weekend utilization is very less. So based on that, whichever minimum pods we have configured, it will be running those. So once that target increases more than 70%, it will start creating another pod, and it will serve the okay. And the next is the dashboard. Dashboard, it will be very much useful to for the managers level and all, like who all want to see the metrics, like what are all running and all those things are useful. It will be useful for them. Default, we have a Kubernetes dashboard available, and we can deploy that. Here I've given the deployed steps. Unfortunately, I cannot deploy it because I already have deployed and working one. So I'll explain you those. So we need to just, this is the URL provided by Kubernetes. We can deploy this file. And here, this is the, administration user custom role binding. We need to deploy this, and we need to, normally the Kubernetes, it deploys on the cluster IP. So if at all you want to expose it outside and use it, we need to use a node port. And this is the command to generate the token of the server. Here I have already generated it, and I'm just showing it. Here you can see how can generate. Okay, let me copy this and see. copy paste issues. Yeah, here is how the token is generated. I already saved the token. So if at all you redeploy a dashboard, then you need to generate a new token and use it. If at all, if you just don't touch it anything, you can use the same token. Here you can see like how many names, what all the namespaces are available, everything you can see. Suppose I go to dev, how many deployments are there, how many cron jobs are running, how many, I don't have any daemon such cron jobs. So how many pods are there, how many replica sets are there. Okay, so how many ingress services. So all this is like, instead of typing each and every command from the command line, you can just see monitor everything through this dashboard. It is also backend, it will interact with the API and gets the information and show it in a graphical manner. So this is Kubernetes dashboard. If at all, okay, I just wanted to tell you one thing. We have like option called let's play with k8s.com, where you can, join it with your existing GitHub credentials, or, it provides sessions like for 4 hours. You can create instances, Kubernetes instance, and you can do all the practice. Those who cannot install, a Minikube or anything, you can just practice in this. You can create nodes, cluster everything here, multiple nodes, and you can practice everything here. This is the URL. I'll share it in the chat. So this will be useful. Yeah. Okay, so any questions or anything, please let me know. Hello.
Yeah, doesn't look like any questions. So
Hey, Rambabu, excellent session again. Thank you.
Hello, this is Abdul.
Hey, Abdul.
I just want to introduce about our job channel and tech teaser.
Yeah, go ahead, please.
Yeah. Hi, everyone. We have a job channel in our teams. If anyone looking for a job, you can suggest them to come and visit our job channel. Or if you have any openings in your organization, you can come and post channel. The main purpose is to help each other. Apart from that, we have a tech teaser channel too. If you want to share any knowledge or improve your knowledge, you can come and visit this channel. It's just like a give and take. Thanks, Kada. That is from my end.
Thank you so much, Abdul. And I also kindly want every one of you, including you, Rambabu and Kavita, there is a 5G meetup coming up on September 18th. It's in the Eventbrite. I sincerely, kindly request you to go and register and attend and support this initiative. So that's pretty much. And before I close the call, I wanted to really thank Ram Babu and Kavita from Wavelabs for supporting. I know that it's not easy. It's Saturday evening, night time from India to really help us all learn. Big thanks to them and big kudos to them. I would appreciate everyone giving them a round of applause, please. Awesome. Perfect. Thank you very, very much, Ram. Kavita, I really appreciate it. I'll send an email later today, thanking you all, copying to the leadership team and Wavelabs for supporting us. Thanks again, once again, everyone. You all have a wonderful day, wonderful long weekend. Enjoy yourself. I'll see you in our next program. Next Wednesday, we have the Selenium automation program, and also we have a lot of other programs starting to happen. So looking forward to see you all in those programs. Take care, guys. Bye-bye.
Thank you. Happy weekend.
Yeah, bye-bye. Thank you, Ram.